Our last lesson in Unit 5 is proportions in triangles. We're going to start off with a theorem, its converse, and then a corollary, and then the rest is just some practice problems. So this should go pretty quickly. The triangle proportionality theorem, better known, I think, as the side splitter theorem, says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So here's our parallel side. It's parallel to one side of a triangle. So TU here is parallel to QS. And it intersects the other two sides of the triangle. You can see that TU is intersecting these two sides of the triangle. So what we know because of this theorem is that it divides QR and SR proportionally. All right, and then of course we have this converse of that theorem, which is also true. It says if a line divides two sides of a triangle proportionally, so it just says the converse, then it is parallel to the other side of the triangle. So it would just be the converse of this. If QT over TR equals SU over UR, then TU is parallel to QS. Simply the converse of the side splitter theorem. All right, and then we have a corollary. The corollary says if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So if R is parallel to S, it's parallel to T, then I know that UW over WY equals VX over XZ. Those segments that the transversals are divided into are proportional. So let's see how that, oh, sorry, we got another one. I forgot about the triangle angle bisector theorem. It says if a ray bisects an angle of a triangle, so that's what's happening here, CD, then it divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. So look here, if CD bisects angle ACB, and we know it does that because these angles are marked as congruent, then I know that AD is to DB as AC is to BC. Or I could have written it this way. I could say AD is to CA as BD is to CB. And if you look at that, I would get the same cross product, right? AD times BC. I just switched my letters around. But anyway, that ray divides this opposite side of the triangle into segments that are proportional to the lengths of the other two sides of the triangle. So let's see how these theorems are going to work for us. Okay, so this is the side splitter theorem, right? Side splitter theorem because I know this is parallel to this and it intersects the other two sides of the triangle. Therefore, I know the two sides of the triangle are in proportional segments. So I know that 9 is to 6 as NR is to 4, right? Or I could say 9 is to NR as 6 is to 4. It's all going to be the same. I'm going to get 6 times NR equals 36. So NR is going to be 6 there. That's all you got to do. Side splitter theorem. Okay, here's the corollary. Here's the corollary to the side splitter theorem. How do I know I can use it? Because these three lines are parallel. They have to be parallel. So you wouldn't know that you could use that corollary if you didn't have these markings on there. So what do I know? I know that 4x is to 5x as 4x plus 8 is to 6x minus 10. So what am I going to do first? I'm going to simplify this ratio. And now I'm going to go ahead and take the cross product. So I'm going to have 24x minus 40 equals 20x plus 40. Right? So let's see. 24x minus 20x is 4x. And that equals 40 minus, no, 40 plus 40. If I add 40, 4x equals 80. Therefore, x is 20. So that's all it said, solve for x. But if it wanted me to find the length of each one of these segments, then I know that would be 80. That would be 100. This would be 88, right? And 120 minus 10, that would be 110, I believe. Well, this right there. So I could find, be careful that you ask the question, answer the question you're asked. It did just say solve for x though. Okay, what is the length of GH? This little piece right here. So what you actually have here are 4 more problems. I want you to work these problems and then come back and check your answers with mine. Okay, so here's the first problem. I set up my proportion. 28 is to 30. 28 is to 30 as GH is to 25. And I did switch my means here because, as you can see, that's going to give me something over here that I can simplify down to 6/5. And then when I take my cross product, I get 6 times my unknown equals 140. And then when I simplify that, I don't get a nice integer like I was hoping for. I actually get 70/3. So I think that's right. Let me know if you got a different answer, but that's what I'm getting. Okay, so when we go to the next one, we have the triangle angle bisector theorem. So once again, set up my proportion. I know that 12 is to 8 as this part is to this part. So I have my proportion there, and I simplified 12/8. 4 goes into 12 3 times, 4 goes into 8 2 times. Then I took the cross product, and once again I did not get a nice sweet answer like I would have hoped for. I got x is 36/5, and since I had called QR 18 minus x, and I had to plug that in, QR is 18 minus x, which is 18 minus 36/5. And when I do all that fancy math, I got 54/5. Of course, I could check this, but it is the Wednesday before Thanksgiving, and I'm hurrying, so I'm not going to check it. You should definitely check yours and make sure that 54/5 is the correct answer. I don't see an error in my math. It doesn't look like an answer I want to get, but that's what I got. So you check it. Make sure it's correct. All right. In this one, once again, we have the triangle angle bisector theorem. I did the same thing, set up my proportion, don't see anything wrong with it. And this time I did get a nice answer. I got that x equals 12. And if x is 12, how much is the other piece? Well, that would be 9. So I can see that, let's see, 16/12. Is that equal to 12 over 9? That's going to be 4/3. That's going to be 4/3. So, yep, that one's good. And then finally, this one is back to the side splitter theorem. It just comes out ugly because, once again, I get a quadratic. 12 is to 7x as 2x plus 2 is to 5x minus 1. I get a quadratic here. When I get to this point, guys, I got a greatest common factor of 2 in each one of these numbers. When I factor it out, I'm left with 7x squared minus 23x plus 6. If I divide both sides by 2, then that 2 is going to disappear. And then I'm just left with factoring this terrible trinomial. And remind me in class, and I will show you a nice handy dandy way to factor a trinomial like this when your first term doesn't equal 1, so that you don't have to guess and check. Because what I did is I guessed and checked, and I finally ended up with these two factors, and when I solved I got x is 2/7 or x equals 3. I probably should check both of those answers to make sure they work, but once again I'll leave that to you, and we will end this lesson and this unit here, and have a nice day.